All right, first example, we're going to follow those 3 steps. Step 1 was find vertical asymptotes. So we're going to find vertical asymptotes. To do that, we take the denominator, set it equal to 0, and solve. So x minus 3 equals 0 gives us positive 3. So there's a vertical asymptote at x equals 3. Next, we're going to find horizontal asymptotes. So HA at, we know it's a y equals for a horizontal asymptote. And we have to compare the degree of the numerators and denominator. So here I have x, which is a degree 1, and x, which is a degree 1. Since they're the same, I'm going to look at the ratio of lead coefficients. When there's nothing there, that means there's a 1 and a 1. So it's 1 over 1, which is just 1. So the HA is at y equals 1. Then I want x-intercepts. To find x-intercepts, we take the numerator and set it equal to 0. We have x plus 4. X plus 4 equals 0 gives me a negative 4. So x equals negative 4. But we can't leave it as x equals negative 4 because that's the equation of a line. Just like the vertical asymptote is x equals 3. So x equals negative 4, that's a vertical line. So that's the x value of the intercept. So I need to turn that into a point. The point is negative 4 comma 0. All right, so I did step 1, 2, and 3. Now I can set up my paper to graph. I'm going to need an x-axis, and I'm going to need a y-axis. And you should be making nice, neat graphs with rulers. There's rulers over there on top of the filing cabinet. The vertical asymptote is at 3. So 3 is 1, 2, 3. Here's my vertical asymptote. Then I want to graph my horizontal asymptote at y equals 1. And then I want to graph my x-intercept at negative 4, 0. 1, 2, 3, 4, 0. I'll mark that, I guess. All right, so that's a pretty good start to my graph, but don't have a graph there yet. So I need to test the vertical asymptote, my red line, splits up my x-axis into sections. I have the section to the left of it and the section to the right of it. Sometimes you have more than one asymptote and then you have more sections. So I need to figure out where my graph is on the left-hand side of the asymptote. I can tell by my x-intercept it's going to be down here. But just to verify what the graph is going to look like down here, since I have the y-axis, I'm going to go ahead and get the y-intercept also. Let's find out where it is, because we're doing this with no graphing calculator. So the function, I'm going to do f of 0. That's when x is 0, and that will tell me where the y value is. So I plug in 0 into my function. So I have 0 plus 4 over 0 minus 3. So it's negative 4/3. So that is the point, 0, comma, negative 4/3. So 3/3 is 1. So if I went negative 1 and then a third more than that, about right there. Okay, and I see I have a vertical asymptote, and from here it's heading that direction. So I know, oh, I missed it. I meant to hit it. Whatever, close enough. If I was using a pencil, I'd erase it and fix it, but I'm not. And then I have a horizontal asymptote. So from this x-intercept, I can continue my graph towards the horizontal asymptote. And then I need a graph on the right-hand side of my vertical asymptote. Well, I don't have anything plotted over here on the right-hand side. So I need a test point. This is the asymptote's at 3, so I could just go over one more space. Let me test when x is 4. Where's the point land? So f of 4 gives me 4 plus 4 over 4 minus 3. So that is 8 over 1, which gives me the point 4, comma 8. So when x is 4, y is 8. X is 4, 1, 2, 3, 4, 5, 6, 7, 8. It's a point right here. Okay, so from there I know I'm heading towards an asymptote, and since I'm on the outside, I'm heading towards this asymptote. I could do another test point if I wanted to be really exact, but I'm really just doing these. Okay, that was kind of okay. So it would look like that. All right, so there's the graph. And it should make sense because it's not real. This equation is not that different from the parent function. Sure, there's an extra x, and it's plus 4 on top, and it's minus 3, but it's not like reflected. There's no x squareds in it. So it generally looks like the parent function, where there's a curvy part up in the top right and a curvy part in the bottom left. It's just been moved around a little bit. So there's that one. So then, let's look at the next example. If we have f of x equals 3x squared minus 3 over x squared minus 9. Nope. All right, so this one, hopefully whenever you're looking at this function, it should be screaming at you to factor this, especially the 3, right? Greatest common factor. That should be painfully obvious that you have a 3 that you can bring out in the numerator. Then you would have x squared minus 1. And in the denominator, you have x squared minus 9. This one's my favorite factoring because it's so easy. You have a perfect square, x squared. You have a perfect square, 9. It's subtraction. So you're going to do 1 positive and 1 negative, set of parentheses, positive, negative. Square root of the first term is x, so that gives you the first term of each. Square root of the second term is 3, so that gives you the second term of each. And it's factored. And then I look at it again, I'm like, oh, wait a minute, that's x squared minus 1. That's a perfect square. That's a perfect square. That's subtraction. So I can factor that more. So I have 3, x plus 1, x minus 1, over x plus 3, x minus 3. So now I've factored. If I canceled a factor, I could do that. It would create a hole in the graph. There's nothing to cancel here, but if I did. But if you can factor or simplify your function, you should do that. And then go to your 3 steps. Step 1, vertical asymptotes. At x equals what? So I'm going to take my denominator and solve it. It doesn't really matter which one you do, but a lot of you will still make the mistake of forgetting the plus or minus when you do the square root. So I would take the factored one. X plus 3 equals 0 gives me a negative 3. So x equals negative 3. X minus 3 equal to 0 gives me a positive 3. So x equals positive 3. So I have 2 vertical asymptotes. Okay? That was step 1. Step 2, horizontal asymptotes. Y equals. Horizontal asymptotes, we look at the degree of the numerator and the degree of the denominator. Again, it doesn't matter which, if you look, I like the standard form version best, personally, because you can see the power. But I could also use the factored form by counting up the x's. So I have x to the first, x to the first. So that tells me that's a degree 2 in the top. X to the first, x to the first. It's a degree 2 in the bottom. Or I can also see it here in this form, degree 2, degree 2. So they're equal. So I look at the ratio of lead coefficients. 3 over 1. So that is 3. I have a horizontal asymptote at y equals 3. Then I need the x-intercepts, or x-intercept, however many I have. To find that, I take the numerator, set it equal to 0, and solve. So I'm going to bring the factored form. X plus 1 equals 0, so x equals negative 1. X minus 1 equals 0, so x equals positive 1. But these are points, not lines, so I'm going to write this as a point. The point, negative 1, comma 0. The point, 1, comma 0. All right, I've done the 3 steps, so then I'm going to start my graph. So I can figure out where my test points are going to be when I'm ready to graph. All right, there's that. Vertical asymptote. Negative 3 and 3. So I need to go 1, 2, 3. 1, 2, 3. Two vertical asymptotes. Horizontal asymptote at y equals 3. So there's the horizontal asymptote. Then I can plot my x-intercepts. Negative 1, 0. Positive 1, 0. Okay, so seems like I have a good start. But my vertical asymptotes split this into 3 sections. 1, 2, and 3. So I need to know, what does the graph look like on the left? It doesn't really matter where you start. I like to start on the left. So I need a point to the left of the asymptote. So the asymptote is at negative 3. I'm going to use negative 4 because I don't know if my graph is in the top or in the above the horizontal asymptote or below the horizontal asymptote. But I do know the ends are going to approach the 2 asymptotes, the blue one and the red one. So I'm going to try negative 4. So I'm going to do f of negative 4, where I take negative 4 and plug it in. So I get 3 times negative 4 squared minus 3 over negative 4 squared minus 9. And it gives me 45 over 7, which is fine, but I don't really know what 45 over 7 would, where to graph that. So you just do 45 divided by 7. It's approximately 6.4. So at negative 4, I'm going to go up 1, 2, 3, 4, 5, 6.4 is almost to half. So my point's there. Since I'm on the outside of the graph, I know the end behavior is going to approach the asymptote, the horizontal asymptote. So it's going to approach the horizontal asymptote that way. And then as I go to the right, I approach this vertical asymptote. So that's what the graph looks like. So I drew the line?
5 over 7.
Okay. Well, 45 divided by 7 is about 6.4. So this gave me the point negative 4, 6.4. So negative 4, 6.4 gave me this point. And since I know this is a rational function, and the graph is going to approach the asymptote for the end behavior to the left, And then as I move to the right, it's going up towards infinity. And then I need to test, you know what, let's just do the two outsides first. So then I'm going to test the far right, because on the middle it's a little weird. So the far right, I need a point to the right of that asymptote. That was at positive 3, so I'm going to test the point positive 4. So f of 4, I'm not going to write it all out. It also gives me 45 over 7 when I calculate it. So I know that gives me the point 4 and about 6.4. So I go up to the same height, but on the right side. So my end behavior of the function is approaching that horizontal asymptote at 3. And then as I go the other direction, it's going up towards that asymptote. And then there's the question of what's really happening in the middle. The reason I did the outsides first is because when you have multiple vertical asymptotes, the horizontal asymptote only applies to the outsides. It only applies to end behavior. It can cross over the asymptote between the two vertical asymptotes. So this blue right here isn't really a roadblock or doing anything to my graph. So I don't know if this is going like that. I don't know if it's going this way. So I'm going to have to test in here to see what's going on. But it's okay. Your graph can touch and cross a horizontal asymptote if it's between two vertical asymptotes. Because the horizontal asymptote is only applying to the end behaviors. So the outsides. So that's why I did those first. And then the middle part's just kind of its own thing. So between these two x-intercepts is the y-axis, so that's a good point to test, is the y-intercept. Where's the y-intercept? So f of 0. So I plug in 0 and I get negative 3 over negative 9. So that gives me 1/3. 1/3 is approximately 0.333. So that's the point, 0, 0.3. So positive third, so it's about right there, a little less than half. That's enough to show me that it's going to have to connect that way. And then as I move from the middle towards the left, I'm going to approach that vertical asymptote, so it has to go like that. And as I move from the right intercept towards the right, I'm going to approach the positive vertical asymptote like that. And now I'm done. So this one didn't cross the horizontal asymptote, but it could have. If this would have been a negative 0.3, then these sides would have gone up also. All right, so your assignment today, I made it really short for you. It is page 138, numbers 13, 15, and 17. You're doing these with no graphing calculator. Graph them by hand the way I just showed you.